Right. Hi, everyone. Sorry about that little interruption thingy. Right. So welcome to our. I'm Sebastian.
I'm Lali. And I'm Hannah.
And and who are our guest speakers?
Hi everyone, my name is Sydney and I'm with Air Guardian presenting today.
Hi everyone, I'm Michelle. I'm with Sydney and also part of Era Guardian.
So if you guys have any
It's
questions, feel free to put them in the Q&A and we're going to be answering them at the end of the presentation.
Okay, I will start sharing my screen for the presentation. Can everyone see this okay? Good?
I see it. Okay.
Perfect. Okay, so today we're going to be doing a presentation with you today about how to build a air quality sensor out of Legos. See a picture here, and we can just get right into it. So on the agenda today is we're gonna tell you a little bit about us, meet the team. You're gonna learn a little bit about air quality and air sensors. We'll be playing a couple of videos that we created to show you how the air sensor is built. I'll go into a little bit about our Lego air sensor learning module that we created, and then we can go over any questions you guys have. So, Michelle, take it away.
Hi everyone. So my name is Michelle Mendoza. I'm the program director to Era Guardian. I graduated back in 2021 in public health and had a minor in conservation natural resources. I got into air quality shortly after graduating college at UC Berkeley, and that's really where Air Guardian started. It started off of a student. Her name's Paloma. She was also a UC Berkeley graduate. She recognized a need in her community for resources such as air quality monitoring, which we'll get into what that means. And well, I hopped on with her in the project. It was just a little pilot study, which was during the pandemic. We tried to help buildings and churches to open up safely during the pandemic. And to do that, we needed to give them suggestions for having good air quality inside. So after that, we found a bunch of people that were interested in doing more projects that were more centered on indoor air quality. And we came across this Lego project that originated from Utah, actually. And I'll get a little bit more into that. But Air Guardian, as a program now, provides this Lego workshop to teach others about air quality in their communities and neighborhoods. And we'll get right into it. And I just pass it on to Sydney.
Yeah, hi everyone. Again, I'm Sydney. I'm Air Guardian's outreach coordinator and also curriculum designer. So I've been working here for about 2 years with 2.5 years now with air quality. Before that, I was a teacher, so I taught third grade back in the day, and I also graduated from UCLA with a geography and communications degree. And also have a master's degree from the University of Cambridge in Anthropocene Studies, which studies climate change and human interaction, ecosystems type stuff. And my thesis was about science education. So this is really something that I care a lot about. Air quality has a lot of implications for public health and the environment, and also social issues. So it's just a really good space to be in and also to teach others about, because sometimes air quality can be, since it's something that we can't really see with your eyes a lot of the time, it's something that we can bring awareness to for communities. So that's sort of how I got my start. And also feel free to ask Michelle and I any questions generally about college or studies. If you don't have any questions about air quality, we're happy to provide that information, especially because we didn't graduate too long ago. So we can be a resource for you there. But that's us. That's the Air Guardian team. So we can get right into the content for you guys. So let's start with just the basics, what air quality is. So if you don't Okay, recording now. So if you don't know, air quality is what tells us how good our air is, basically, based on levels of air pollution. So there are many different types of air pollution. They come from many different sources, depending on environmental effects and things like that. You see in this image here some different types. We have CO2, which is what you typically hear about when we talk about climate change. But also those nasty things up there, diesel, PM 2.5, and ozone. Those are also types of air pollution. Poor air quality can lead to some bad health outcomes over time for people exposed, and as I said, can lead to the acceleration of climate change over time. Quickly, so some sources of air pollution. There are many different ways that the air pollution sources can be categorized. This is one example that shows that categorization based on how they function, rather than like their size or anything like that. So we have mobile sources of air pollution, stationary, area, and natural. So mobile sources of air pollution are mobile. They're things like cars and buses and planes and trains. They all are mobile sources of air pollution. So whether you're driving across town or flying across the globe, that would be an example. Stationary sources are things like they stay in one place or are permanent fixtures or mostly permanent fixtures of an area. So things like power plants, industrial sites, oil refineries, things like that. They are big contributors in this category to air pollution. Next, we've got area sources. This is referring to how the land itself contributes to air pollution. So things like agriculture or just the cities themselves, or even smaller areas like just the fireplace in your home. Those are area sources. And then lastly, natural. We all might be familiar with these. It's just what happens in nature. So dust blown around by a tornado, that's a type of air pollution. Same with volcanoes. When they erupt, they release chemicals into the air. And more recently, you might have heard about the wildfires in California. We forgot to mention, Michelle and I are based in California. I'm in San Diego, California, and Michelle is up in Northern California in Sacramento. So that's typically what we think about when we think about a natural source of air pollution, is about wildfire. So depending on where you are in the world or in your city, you might see all types of air pollution sources where you live. So we're hoping you can put in the chat just as sort of an interactive thing if you can think of an example in your city of an air pollution source. So you might be like, well, there's a lot of traffic on this freeway, or I see smoke coming out of this area. So we'd like to hear from you if you can think of any air pollution sources in your city or your community or even your neighborhood or your house. Just get you thinking about the different ways air pollution can come about. But we can move on.
Yeah, and Sebastian, Hannah, if you find any in the chat that you would like to read off, feel free to as well.
We'll do.
We
Will
will.
do.
Okay. And there's also specific types of pollution. I know Sydney has already listed off, but the one that we'll be focusing on is particle pollution. So particle pollution, also known as PM 2.5, which Sydney mentioned earlier. The 2.5 really is just to measure how small it is. Particulate matter is so small actually that it can go directly into your lungs, which is why we talk about health. And that's why it's so important, because this type of pollution, it's so small that it stays inside of you. It goes into your lungs and it can cause problems down the line. So like the image shown, the many sources that Sydney just mentioned, they come from outside. They can come inside in your home where you stay most of the time. 90% of our time's inside anyways. There's different ways you can, breathe it in. And that's how it's introduced into your body. And so fine particles coming from, your cars, wildfires, industry, they can cause problems for many people over time. And some people, it affects them more, like elderly people, children. So knowing these things, there's a lot of interest in trying to figure out how we can measure this particle pollution as a way of protecting our communities, protecting the people who are most affected by particle pollution.
Yes, exactly. And I see something in the chat from fourth graders. I love these examples. We have chimneys, carbon monoxide. That's a good one because that's something you can't smell. So we need detectors for that. Exhaust from cars is a big one, especially in California. Car exhaust is one of the major points of air pollution in maybe not just California, but for the whole world. Vaping and smoking is a good one. We hear that a lot in when we do workshops. It affects especially indoor air quality when you're doing it in an indoor space. And also planes, that's a great one too. So all of these release different types of air pollutants that we can see, that we can smell, and sometimes that we can't see or smell. So thank you for your participation. Okay, moving on. Thank you, Michelle, for particle pollution. All right, so let's go into how we can measure air pollution. Like I said, because it's something we can't necessarily see or smell all the time, we need technology to tell us what the air quality is. So we measure air pollution with air sensors. So air sensors, many different types of air sensors, they can use a variety of methods to detect air particles. Our focus today is on the light scattering method. So we see a picture here, a diagram. Basically, a light source illuminates a pathway of air, and the light bounces off particles in the path. So you see here, these little circles are particles. They have a light beaming through them, and then light gets scattered all over the place. So when the particles scatter the light, the detector up here in the right-hand corner can actually measure how much light scatters, and they can get information about the particles in the pathway. So basically, if we think about this, that means the more scattered light there is, that means there's more particles because there's more points for the light to bounce off the particles, right? Like if you've got nothing in this pathway, it's not going to bounce off of anything. So the air quality is going to be good. If you've got a lot of things in the light path, then that's going to mean there's more air pollution or more particles in the path. So generally, when we talk about the light scattering method, the more scattered light, that means the more particles and the worse the air quality. We don't want all of those particles in our air, right? So that is one method, and that's the one that our LEGO air sensor uses. So we can get into that. Okay.
Right, so the Lego air sensor was a project originally created for a competition in Utah. The chemical engineering group at the University of Utah found a way to bring cheap pieces together to make a very complicated air quality sensor, or at least an example of it. And we'll talk a bit more about low-cost sensor technology, which really just is a fancy way of saying something that you can buy and it's not going to be too expensive. But recognizing how great this Lego air sensor is, we decided to bring it over to California because it's a great way to teach people about low-cost air sensor technology, the fancy word, and also address like how is it that we can measure our air quality, and what can you do with this information in your community, in your classroom, at home, or even outside. So how this Lego sensor works is, like Sydney just mentioned, it has a light source because you need light for the light scattering method. And that's going to come in the little light bulb where you can see Sydney circling. There's a fan that's going to cause air to flow through our path. And then we have a detector, which is going to measure how much light is scattering inside of that pathway. And this pathway, by the way, is all the Lego parts you see. Those are the walls of the path. And in terms of the design of the air sensor, so things we want to keep in mind is we don't want any stray light to come inside of it other than the light that's coming from that source. So that's why there's going to be a roof put over that light path so that we don't have any light leaking inside from anywhere, really. We want it to be as dark as possible. So that way the only light coming is from that little light bulb that's inside of the pathway. And we also want to make sure there's an opening so that the air can flow inside. It's why the opening is placed in an area where it won't allow light to leak inside the path. We just want to give an opening for air to come in. The fan is pulling in air. So that would be the opening we allow for air to come in. So that's the design of this LEGO air sensor. And again, it's not meant to actually give you too much information like the fancy expensive ones, but it will show you how they work. It teaches you about particle pollution, and it also talks about one of the ways we can measure, which is through the light scattering method.
Absolutely. Thank you, Michelle. I just want to point out here, I will go over this next, but this is what it's actually reading. So when the LEGO sensor is turned on and ready to go, the lights will light up depending on how many particles that the detector is detecting. So we want a smaller amount of lights because that means there's a smaller amount of particles. Okay, let's get into what's the components of all this sensor here.
Right, so you're going to need your Lego bricks because you're going to create your walls. You're going to need some base plates, which, as you can see, you have your main floor, the purple, and then you'll have the 2 gray base plates, which one will be the floor for the wall, and then another one that's actually the roof. And then the SparkFun red board is the brain of the whole thing. It's what we tell the instructions of what we want it to read, how it's going to read it. So it's like the chip of a computer. It's really telling you how this whole thing works. Without it, it wouldn't work. And then we have our battery. Our battery is what powers the whole thing. We have our LED light on the bottom left. That's our light source. We have this small fan to pull the air in. And then photosensitive resistor really is just a way of saying it's sensing whatever you want it to sense, which in this case is the particles. And then the NeoPixel stick on the bottom right, it's going to light up because we give it instructions on how much it should or should not light up based off what it's reading. So they're all parts.
Yes, absolutely. So when you see these wires coming out, those wires, which you'll see in our video, attached to the brain here. So the brain tells the information from the wires is powered through the red board, or you can also use this type of board here. The Lego board is also compatible for the air sensor. Okay. Let's get into it. So we're going to play 2 videos, YouTube videos. These are videos that Michelle created, where she's going to go over the demo of how to build the air sensor. And then we're also going to play a next video about wiring the air sensor. So putting all the wires in there. So please let me know if you cannot hear the video. We tried it out, but let's see.
You are now ready to build a LEGO air quality sensor. We'll start with the light path. You should have a 20 by 20 LEGO base plate, 2 20 by 10 LEGO plates, a fan, an LED light, a detector, a NeoPixel stick. We'll be using the LEGO Uno R3 controller board. You're going to take your 20 by 20 base plate and attach one of the 20 by 10 LEGO plates, and this will be on the side without the Arduino Uno board, and you'll have your light path on top of this. To start, we'll build the walls of the light path, making them about 3 LEGO bricks high. Let's refer to our light path image to see where to place the LEGO bricks. Now, with that image in mind, go ahead and build your light path. you reach this point, notice where to place the detector. It should be in between some Legos that stick out from the light path, creating a 90-degree angle. You're gonna place the detector in between Lego bricks, one at the bottom and one on top. This will be to block stray light. Place it down in between two walls of Lego bricks, similar to the first one, and continue building your light path. Now for the second placement, you're gonna wanna build the wall to create a 90-degree angle like before and have the wall stick out. This is where you'll place your fan and have the sticker facing outward. And you're going to use double-sided tape and you're gonna place it in between your fan. Once you have tape on both ends, place them in between the walls. Now you're gonna continue building the wall for the final placement. You're gonna grab one of the small little Lego bricks and place your LED light component on top, and place another small Lego block similar to this one to block any stray light. Once you're done, you're gonna place the remaining 20 by 10 Lego plate on top of your light path. And now we're gonna place the Lego Uno R3 board onto our plate. You can get some double-sided tape to adhere it to the board. And you're gonna want it on the right lower corner of the board, just because you'll be having all these wires wired in later and you want to have space. Next, you're gonna want to grab your NeoPixel stick, maybe raise it up by 3 Legos for consistency. Once you have your 3 Lego blocks underneath, you can place it down on the left lower corner of your board. You are ready now to wire up your air quality sensor. Good job.
Amazing. Good job, Michelle. Okay, so now that we've built our Lego air sensor, the light path, right? The light path we were talking about, let's look at wiring it.
You are now ready to connect your main components to the microcontroller board. We'll be using the Lego Uno R3 controller board. There are other boards such as the Arduino Uno R3, SparkFun ESP32, among others that you can check out in the resources section. You'll notice that each of these components has wires in different colors, and each color serves a specific function. The black wires, for example, connect to the ground or GND pin. The power wires, which will be red or orange, go into the voltage slots. So we're gonna follow this diagram to see where each wire goes on the board. Let's start with the NeoPixel stick, which is what will give us our air quality readings. The black wire will go into a ground pin. It will be the bottom first one on the left. The red wire should go into the bottom 5 V pin. The yellow wire will go into the top pin labeled 6, right up here. After you've connected the wires, you can move on to the next component. So let's move on to the LED component. Your LED component has a red wire and a black wire. The black wire will go into the top ground pin, just like that. And then the red wire is going to go into the bottom power 3.3 V pin. And now we can work on our detector. You're going to put black ground wire into digital pin 2 at the top, and your red wire is going to go right next to it on the left, digital pin 3. You're going to put the green wire into the A3 analog pin in the bottom right here. All that remains is your fan. So you're gonna grab your black and red wires from your fan. The black wire for your fan is gonna go in the bottom ground pin. And with your remaining wire, your red wire, you're gonna put it in the VIN pin, which is also for voltage. Looks like we're all done with wiring. Make sure to double check everything, that it's in the right place. Next, we'll dive into programming the Lego Uno R3 board to get your air quality sensor on and working.
Cool. So we will not be programming today, but just so you guys know, so you saw Michelle put those wires into the different pins, right? We have an air quality scientist on our team that created that code, and he created that code to basically you program it into the board, and it will tell the board, like, when you put a pin in this, this is what is supposed to happen, right? So that's a very simple version of how he created the code to as accurately as possible, tell us how many particles are in that light path. So thank you, Michelle, for showing us how to wire that, and we can continue.
Right. And so a bit about the Lego air quality sensor and the videos you just watched. So those videos are part of a series of modules. So if you're interested in looking at the rest of those videos, it is possible through our website, which we'll share a bit later. But the whole idea of using this Lego air quality sensor is so that you can understand how you actually measure your air quality. And I also want to give you guys the chance to put in the chat some places you could think of where you would like to place an air sensor. Not necessarily the Lego air quality sensor, it could be that, but if you had an air sensor that can tell you what your air is like, where would you want to put it? For example, I have one in my room because, fun fact, if you're measuring another type of source of pollution is carbon dioxide. If you have high carbon dioxide levels in your room, you could actually start to feel sleepy because that's the effect it gives on you if you don't have enough oxygen in the room. So
Yeah.
I have a sensor in my room so that if I start to feel sleepy, I look at it to see what's the air like in my room. Oh, maybe I should open up the window. But that's just an example.
Yeah, in the chat we have some people agreeing with you, Michelle, in their room, in their home. That's a great place to put it. New York is a cool example because that's a city that we think of that might have a lot of air pollution, right? A lot of cars, a lot of big buildings, ships, all sorts of things. We have in our room, in the classroom is a good one. We have met quite a few teachers that have air sensors in their classrooms, or at least at their schools. Outdoor in the backyard is always a good one. Like, maybe you got a fire pit going, that whole thing. So there's a lot of places that we can put an air sensor. So if we're curious about what the air is like, the basement's a good one. Maybe there's not a lot of airflow in the basement. You could see how it changes when you move it to different rooms, right? If you go to a room with a lot of fresh air, if you go to, your kitchen and you're cooking something, maybe it's turning red, things like that. I'm loving all of these answers, everyone. Thank you. Near a factory, that's a good idea because that's something that we think of that might release air pollution, right? Wasteland, junkyard, that releases air pollution too. Wow, thank you guys. I'm loving the participation. But yeah, we could move on a little bit though. So I just want to reiterate, so there's no data that's stored in the air sensor. It's purely like real time. You have to be looking at it to see what the air quality is. I'll mention the University of Utah original Lego sensor had like the capability to store data, but it was Wi-Fi dependent. Like it needed to be connected to Wi-Fi in order to collect the data. So we wanted to have a model that did not rely on Wi-Fi so that we can do this workshop and work with groups that might not have, very strong or reliable Wi-Fi. So just thought I'd throw it out there. Yeah, okay, awesome. So now that we've met the Lego air sensor, we know what it's all about. I wanted to point to an example of a similar or an air sensor that uses the same method that you could look up online. So we usually use the example of Purple Air. So Purple Air is an example of a low-cost air sensor. It uses the same light scattering method that the Lego one does with the LED light, except this one uses a laser. So this is a real factory-made air sensor, collects data. Community groups, schools, churches, organizations, and just regular people like me and you can purchase one of these sensors and add it to this network map that you see here on the right side. So networks like these can help evaluate air pollution burdens and risk especially among communities that are vulnerable or marginalized, that might have data gaps in them. So low-cost sensor networks like this can fill gaps in the existing global and local air quality networks, and it also encourages more community engagement in advocating for healthy air, in knowing your air quality. So it's just a super great way to sort of fill gaps. So I have like a link here to Purple Air. But if you ever I use Chicago as an example because I think that's where our host school is. But there's a lot Purple Air sensor networks all over the country. So you can go to purpleair.com and click on real-time sensor map. Type in, wherever you are or wherever you want to see these air sensors. And if we have time, I'll try to show you the map. We'll see if we have time. But it's super interesting. You can click on each one of these little circles and it'll tell you the air quality and air quality over time. It changes and updates every 10 minutes. So super good. As you can see, when I took this screenshot, the air quality was really good, all greens. So that's what we love to see. So just a little quick thing about why low-cost air sensors are important. So when like Michelle said earlier, like some of the high-cost sensors can be like $20,000 or something. These are air sensors that are used like for regulation purposes, the EPA or things like that. But there's like a lot of gaps between there, right? So low-cost sensors cost less, obviously, than the more complex ones, and they can provide real-time data without waiting for the results to be processed. So sometimes with those huge, expensive air sensors, somebody has to process that data and make it readable, make it understandable to us. These low-cost sensors can give us data right now, like what is air quality right now, and that's super useful. Especially useful in schools and neighborhoods, where we want to make quick decisions about the air we're breathing. And they make it possible for all of us, not just scientists, to keep an eye on air quality. This means more people can be involved in keeping our community safe and healthy. Plus, they can be anywhere. So they're small, they're portable, and they can be used in places where bigger, more expensive equipment wouldn't fit. So you see this screenshot here. This was probably a wildfire situation, but you can see all that red there, right? So we can have these air sensors, these small ones, anywhere. And I think that's like a super big advantage. So what can you do, Michelle?
Right. So after getting this information from low-cost sensors, what do we do with it? So one way you could do that is by looking at the Purple Air Sensor map, for example. And if you have air sensors in your classroom or outside, what it can tell you is whether you should stay inside, whether you should go outside, because sometimes the air quality inside could be, worse in some situations. And knowing what the air quality is like, it can help you take steps to either help others locally or even help globally. So there's a bunch of groups that are looking to always help in terms of air quality. So you could always look to see if there are any groups in your neighborhood. Maybe you can volunteer. You could also do like simple activities like using a bike instead of going by car. Maybe carpooling together. So if you're not familiar with carpooling, you and many friends can decide to take one car instead of all of you taking your own cars to one place. I know Sydney mentioned AQI, and the colors that we saw on the purple air map refers to AQI. So if you go online and look up like airnow.gov, it's a government website, it will tell you what AQI is and what that number and color is for your area. This is just, informing yourself of what's your air quality like currently, real time where you're at. You can, check the weather. The weather will also tell you whether there'll be potential bad air quality, like if there's going to be a tornado, if there's going to be a wildfire, along those things. Like these are activities that that air quality might start to get bad. So also preventing those events from happening. For example, like if you know that it's a really hot day, you'll see those signs saying you can't have barbecues out right now. You can't go camping because it can cause a wildfire. And again, if your school doesn't have an air quality sensor, you can always advocate for one. You could do a project like this one. You can see if your school has been thinking of having one, but they need people interested. Or just in general, there's always people interested in wanting to talk about air quality, or there's groups in the city that are already like working to improve air quality, like tree plantings. So yeah, there's many things you can do. These are just some examples. And yeah.
Perfect.
Sydney.
Yes. So I'll just go into quickly. I know we have a couple of minutes here. So now that you've seen, how to build the air sensor, I wanted to just provide, this is maybe more for the teachers out there, but we have free online learning modules for educators that are interested in bringing this LEGO sensor to their classrooms. And just want to go very quickly over what's included in this free module. So the Lego build module itself, this is our website here. We have a full educator guide, which goes through absolutely everything you could need to know about preparing the materials and actually delivering and implementing the build. We have a materials list here with links to everything that you need for the air sensor. Links to all of these videos that we created. We played 2 of them, but we've got a bunch more. As you can see, there is some soldering involved in creating the components, so it could be a whole STEM education module here. And we also have a user manual. So yeah, the educator guide, everything you need. It's got links to all step-by-step videos, materials that you need for each step in each video, guidance on implementation, and we've also standards aligned them to NGSS Next Generation and also to California science standards, but NGSS. And then, so that's the guide. That's where I would point to. We also have a whole module about background knowledge. So kind of the information that I was talking about particle pollution, air sensors, air quality, and environmental justice. We've got all of that in this background knowledge section, as well as an educator guide for that one. And I also created some sample lesson plans and timelines. So if you're like, I want to do a 2-week unit, a 10-day unit, I have stuff for that. So hopefully that is helpful. And then also created some additional activities for the sensor. So there are 4 data collection activities that students can do using either the purple air map or the EJ screen. And we've also got some reading comprehension stuff going here about environmental justice and review worksheets for each video. Some exit tickets. Yeah. That's the whole module. If you want more information, hopefully we can send out a link to our webinar and our website to you all. So take it away, Michelle.
Right. So I do see a couple of things in the chat. So like when building the air sensor, what are the most common mistakes to avoid? So in the video, we do talk a bit about like things that you should look out for, but maybe like the ones that come to mind is making sure that you're going through it step by step and not skipping steps or getting ahead. Like I know in the past we've done the workshop, there were times when people wanted to plug into the power source before everything was wired in and we could check the wires. maybe like where they're placing the components, like where you're putting the fan, where you're putting the light. If it's not placed in the right place, you might get some funky numbers, and so the lights are going to do weird things because it's not reading right. And I guess more on talking about the sensor itself. So it's not a kit that you can just buy. This is like a do-it-yourself kit, meaning you have to buy all the little parts to build the sensor itself. I will say I had no experience whatsoever building this sensor first starting off. So I had to learn how to solder. I had to learn how to put things together. But once you figure it out, it's not difficult, really. The more difficult part is the coding and programming, but that's why we have that already created, written out by an air quality scientist. So all you have to do is download it. You don't have to worry about programming. All the steps are in the module. But when it comes to the sensor itself, so everything that comes, and you'll see that in the educator guide and stuff, but when you buy things in bulk, you get the most from your money, basically. If you're only buying like one sensor, it's going to be pretty costly because you need to buy like all the tools you need to, actually solder and create the components and stuff. So if you're having like 6 sensors, which you can distribute among like other teachers, other classrooms, even in the same districts, like this is more for our host. If there's grants or programs that are happy to like fund air quality efforts, which we have met others in California that have, they can help pay for those things. So that way the teachers themselves don't have to pay for it. So that's something, a way you can potentially look to pay for these supplies, because I know someone else had asked about how durable the supplies are. So like the fans itself, like they can break or rip, but they come in huge packs, like packs of 50 to 100. So if one breaks, you can replace it. And you being the person that knows how to put it together, following all of the videos that we have, everything's laid out, you'll be able to quickly fix it or get another one.
Yeah.
And I know, go ahead, Sydney.
I was just gonna say, in the materials list, we've priced out for 3 air sensors. I think, what is it, 380, Michelle?
Something like that, yeah.
But as she said, a lot of these things come in bulk. So the more air sensors, the cheaper it is. But yeah.
Right. And I just want to quickly acknowledge all of those who made this project possible. Anthropocene Institute helped paid for all of the modules and videos that we created, the workshops we've had in the past in person, and obviously the Department of Chemical Engineering, Dr. Carrie Kelly and Dr. Butterfield. They're both the creators of the Lego project itself. And there's also a whole other team behind Air Garden that we actually haven't mentioned yet. But there's Rieko Yahima from Stanford, Ajit Garuela, our scientist from UC Davis, Frank Ling, he's the chief scientist, Carl Page, Richard Lee, Paloma Ledesma, and then all the partners listed are people we've worked with this Lego project in the past.
Yeah.
I also want to give us time to answer some questions, and maybe our host can help us in reading those questions.
Yeah.
So we have received quite a lot of questions while the presentation was going. The first one that we have is, can we do anything to avoid these fine particles?
Yeah, I can take that, Michelle. So there's very small instances where there's no air pollution, right? Like there's always something going on, there's always cars in the road. They say, when the AQI that we were talking about, when it reaches an unhealthy level, right? When it's turning yellow, orange, or red, that's when we might want to take precautions where it would actually affect our health, right? So sometimes, like maybe you saw some coverage with wildfires, you can wear a mask or a respirator to avoid getting those really big particles into our respiratory system. That can be helpful. Running air conditioning. I've also got air purifiers going. So Air purifiers and air filters are really helpful in getting rid of some fine particles in your indoor spaces. You might have some HEPA filters, which you might have heard during the first part of the COVID-19 pandemic. A lot of schools put in HEPA filters in their classrooms. So things like that. There's a lot of tech out there that can help reduce your exposure to fine particles, and also just protecting your mouth and your nose when you're like in a situation where there's really heavy air pollution, right? So usually if there's really heavy air pollution that will affect your health immediately, you might see it or hear about it. So that's what I would say, Michelle. If you want to add anything, go for it. But those are some of the main ways that I can think of to try to avoid some of these particles we were talking about.
Right. I do want to point out one of the more cheaper options in like just protecting inside of your air. There's the box fan. This is something that's been going around for a while, but basically you get a HEPA air filter and you tape it to a box fan, and you can use that as a way of filtering your air. But really a simple mask. I would say KN95 is a specific mask that helps filter the air that you're breathing in. A lot of people used it for the COVID because it can filter viruses, but it will definitely help if you're in a situation where there's like a lot of fine particulates. And in some countries, a lot of people wear those masks because the air quality is always bad outside for them, like India, for example. But that's why looking at the AQI, it can help you. It'll give you suggestions like, hey, maybe you want to go inside today because it's not that great. Or for the more sensitive groups, like our older folks and the kids. And yeah.
Cool. Okay. Next question.
So the next question is, if there are a lot of particles, would the light still somehow reach the end of the Lego corridor?
A great question. Yes. So I believe, Michelle, correctly if I'm wrong, in past workshops, we've like brought in a fog machine and a candle and some other stuff to really fill in that light path and test it out. But yeah, it will still do readings like because there will still be light showing into the path no matter what. I feel like the only thing that would make light not hit the end of the path would be something solid in there. So but the particles are fine enough, small enough, to where light will still be bouncing off of them, but not like be completely blocked by it, if that makes sense.
Yeah, so the light should still reach the end of the path. It's
Yeah.
just that a good amount of the light will be bouncing off because of what's inside of the path.
Yeah, it'll be scattered a lot, like we said. Okay, next question.
Okay, the next question is, what made you two want to pursue this topic?
Oh, cute. Yeah, I first started thinking about air quality in relation to climate change and the environment. So that's really sort of was my segue. And now I care a lot about air quality because of its relation to public health. But especially like I keep referring back to the wildfires in Los Angeles, but that was something that shows how certain parts of climate change or general environmental degradation can really impact air quality. So that was sort of how I got into it. That was something that I grew up with, was experiencing wildfires and air quality issues that come from that. So it really sort of took off with when I was learning about the environment. What about you, Michelle?
Wow, I got into air quality because I'm from Stockton. It's a city in the middle of California. It's known for having one of the highest asthma rates, meaning that you can talk to someone at the grocery store and chances are they or someone they know has asthma. The area is formed like a bowl surrounded by mountains. So all of the air pollution from all of the sources we just mentioned stays trapped in the valley. So it's really hard to get that fresh air we've been mentioning because there's nowhere for the air to go. So a lot of people get asthma because of the agricultural fields surrounding that area. So for me, air quality felt like it was one of the more important topics, seeing as like, I have family members of my own who have asthma. And I wanted to know how to protect us. How can community members like yourself, me, how can we protect ourselves? And what is our government doing about it? Like, are there currently programs or projects in the area that I can be a part of? And it's also along the realms of climate change because we wonder like how can we combat climate change? Sounds like a very big thing. The world, is focused on air quality as a whole because air also is global. It's local and it's global, meaning air doesn't recognize borders. So even though we're here in California, if we have a bad enough wildfire and the smoke somehow starts to travel, it can reach other parts of the world because of air travels. And another thing that I'm actually interested as well is water quality, because a lot of these topics tend to relate to one another. So what happens in the air can go into the water, and vice versa. Things that are in the water can end up in the air. I hope that answers your question.
Good job.
Next
Michelle.
question.
Right. So for the next question that we have, if the parts of the Lego air sensor break, are they replaceable?
Right. So that's happened to us in the past where we used the Lego sensor in one workshop, put it away, we come back and maybe the fan wires are ripped, or Legos don't break easily. It's more the wiring, and the wiring part itself, you can easily do that yourself in fixing it, because as you create the components, you're going to become very familiar with the wires. So if a wire rips or breaks, you create a new one and use another piece that you have. They come in bulks again. So we're looking at fans that come in pack of 50. So if one or two fans break, pull out more from the pack. And they're pretty durable. We've used certain Lego sensors for like over 3 workshops. So it really just depends on how frequently you use it. Are they being stored well? Because if you're putting things on top of it, then more chances of it breaking or ripping.
Yeah.
Next question.
I answered a couple of questions in the chat from Larissa. So one of the questions, Michelle, that I think you might know more about is if we can use a different type of Arduino Uno R3 board. I mentioned that we've used SparkFun Red board in the past, but I guess both of our wiring diagrams are specific to those boards. But Michelle, I'm not sure if you had any more info on.
Yeah. So the board that we specifically talk about, which is the Lego Uno R3, there's also the SparkFun Uno R3. These are just different brands, same board. If you use a different board, you're gonna have to change the code. Because remember we told you like you have to tell the brain, the board itself, the instructions to do things. So if you get a different board, it needs different instructions, different directions on how to turn on the light, how to read the particles, all that stuff. So you can, because the board, there's different boards for different reasons you can use them for, but just know that you'll have to change the code. And unfortunately, like we have the code only for the Uno R3 board, but that could also introduce programming to your class. So it just definitely depends on what you're looking for.
Yeah, for sure. Any more questions? I think we're out of Q&A questions. I think I might have gotten to all of them in the chat, but if I missed something, let me know.
There was one other one in the chat earlier. It asks, how does the sensor differentiate between particles that are pollution and those that are not pollution?
Okay.
So specifically what it's going to be reading is the light scattering, right? And the light's going to scatter because there's things in the path of the light. Particle pollution is literally that. It's particles. So there's different sizes, like we mentioned, of particle pollution. So it's going to be reading only a certain size of particles. I'm not exactly sure what the size is for this Lego sensor. I can definitely ask and put that on the website. But, we mentioned 2.5 earlier. There's also sizes of like 10 or 5. 2.5 is just the number that a lot of scientists go off of as the one that's the smallest amount that is most harmful. But they can go smaller. Our
Mhm.
LEGO sensor is only reading a certain size of particles. So it might not be reading all the different size of particles, just there's a limit on what it can read. And that's the instructions put on the board itself. It's telling the sensor, you're only going to be reading particles of up to this size. But again, it's not the particles, it's the light scattering. The light scattering is telling us what particles or amount of particles are in there. So you're kind of making a conclusion based off of what the sensor is telling us. And keep in mind, these are numbers. You have to make sense of the numbers too. I hope that answers that question.
Yeah. I think we also got another question about the costs. So I wanted to just show everyone this, because I think it might be helpful to picture. So the reason why it's 380 that we've calculated for 3D sensors is because you have all of, in the yellow here, all of the sensor parts, right? NeoPixel stick, the fan, the resistor, and things like this. But we also, what we didn't show is that we had to solder like all of these materials together. So part of the cost is for soldering irons, right? So a soldering station, tools, and things like that. So that's part of the cost. And then actually some of the most expensive stuff is the Legos themselves, which come in like a huge set. So that's what we say when we say buying in bulk might be an option, because the units that have only one, like the NeoPixel stick and the board, those are things you need to buy individually. But a lot of these things have like a bunch of pieces in them. So it's really hard to say how much one sensor costs, because a lot of the items that go into the sensor are purchased in bulk, and we wanted to include the tools in there. So it sort of just depends, and I know that's kind of an annoying answer, but it kind of depends what you already have, what the teacher is interested in doing with their class, as far as soldering and preparation of the tools, and things like that. So I hope that helps.
Right. And also, like, part of the modules itself, it has all of the information you could possibly want in terms of air quality. So if maybe this is too costly, you could still go through the entire background knowledge modules to teach about air quality, environmental justice, how this applies to your community. And there's also a lot of activities you can use with the air quality monitoring efforts in your area, like Purple Air, the EJ screen tool, and these are all like monitors already in your area, so you wouldn't have to pay anything. So that's just also an alternative. Our project is just something available if you have the funds, or there's a grant that's currently in your area that would potentially pay this for you. Or maybe there's a bunch of teachers in your schools that are willing to become a part of this. So just some options.
Oh,
I
we're right
think we're running out of time. Yeah.
Yeah,
Thank you
that's
guys
all
so
the
much
time
for
that we
having
have for
us.
today. Thank you so much for your presentation. We really appreciate you giving us the time to learn from you.
Mhm.
Amazing. For our viewers still watching, please join us in our webinar already in progress with Mark Ellis, who talks about the coexistence of wildlife. Great. Thank you so much,
Thank
guys.
you.
Thank
You
Have a
guys.
Thank you.
See ya.
Bye.